Using Nutrient Control Programs video. Today we're going to be outlining how to use the Argus Nutrient Control Programs. Areas we're going to cover today include Nutrient Operator Screen, Nutrient Injection Program, Feed Recipes Program, and a summary. The Nutrient Injection and Feed Recipe programs are highly integrated but separate programs with separate screens. An operator screen, like the one shown, is usually created to help display the unified elements of these separate programs. This makes operating the nutrient system easier and more understandable. Key readings and parameters from the feed recipes and nutrient injection programs were then applied as shortcuts. This screen now functions as the home screen for the nutrient system. With a similar screen to this, you can monitor system activity and navigate to any of the underlying program screens with ease. The nutrient injection program is used to manage the injection equipment. It also defines the contents of up to 14 possible stock tanks plus one acid-based tank. During operation, it continuously calculates output values for each enabled injector, as well as managing injector purging, feed source selection, and flow metering. To accomplish this, it must inject the correct proportions of fertilizer concentrates from each enabled stock tank into the irrigation stream, so the resulting dilute feed matches the current feed recipe. It also must match the overall rate of injection to the current flow rate of the system to produce the correct concentration. The main screen of the nutrient injection program provides an overview of the injector program and menu entries for navigating to underlying screens. We will briefly cover each section that needs to be entered for this program in this section of the video. Injected amounts. This table displays the total cumulative and instantaneous amounts being injected from each concentrate tank. There is a stock tank screen for each concentrate tank on the system, plus an acid and a base concentrate tank. The stock tank screens are identical. Up to 14 tanks can be used for fertilizer concentrate. Use as many as you need to match your injection equipment. Tank 15 is dedicated to acid addition, and tank 16 is dedicated to base addition. Selecting the menu entry for a stock tank opens its configuration screen. The tank composition defines the elemental composition of chemicals in this tank, as well as the overall concentration of dissolved materials. Stock tank external enable is intended to halt dosing from a stock tank when it's empty or when it has some other externally defined problem. Output configuration. You can select an output style to match the injection equipment that you're using. The output type setting is used to select the output style. For the rate output, the program generates a value of 0% to 100%, which translates into volume delivered per second as a percentage of the maximum possible injector rate. The standalone pulse output provides an independent pulse output delivering a fixed volume for each pulse or on time. The minimum and maximum delivery time values can be set from 0.02 seconds up to 5 seconds in 0.02 second increments. The synchronized pulse group 1 to 6 type output delivers a fixed volume of concentrate for a given pulse width that's synchronized with a total of 13 other outputs to ensure none of the outputs are on simultaneously. This is to interleave stock solution injection to reduce the output ripple as measured by an EC sensor. The input accumulator for each stock tank accumulates the flow volume measured by the irrigation flow meter. It acts as a buffer between the inlet measurements and the actual feed injection calculations to carry forward any residual values. The output accumulator for each stock tank is used to sum the calculated required output volume based on the input accumulator and the injection volume calculated in the feed recipe as part of the target ppm. Accumulation only occurs when this stock tank is part of the current feed recipe. Its purpose is to increase injection accuracy by carrying forward any calculated concentrate injection amounts that do not fit in the current pulse. This can be thought of as an uninjected remainder. The nutrient injection program automatically compensates for the elemental concentrations in the inlet water by subtracting these amounts from the recipe before it calculates the injection volumes required to achieve the recipe targets. The nutrient injection program automatically adjusts its injected concentrate volumes to match the current system flow rate. To accomplish this, an accurate flow meter must be correctly positioned in the main irrigation stream. If you set the flow meter type to pulse, enter the volume per pulse in liters using the flow meter manufacturer's information for the pipe size used. Pulse type inputs are typically assigned to IO module channel A or B. Use the raw counter reading from the IO module. If you set the flow meter type to rate, use the input multiplier, input divisor, and conversion factor to convert the reading into liters per second with microliter resolution. Feed request source. It designates which recipe the injector supplies. Whenever the flow meter measures flow through the irrigation system, the injector system must either deliver one of the recipes chosen from a linked feed recipes program or deliver clear water, inject nothing. The injection response can be configured manually or automatically. The feed selection is used to choose between fully automatic feed selection, manually designated feed recipe, or clear water. The feed source status shows the status of current feed requests to the nutrient injection program. This example indicates that a linked irrigation system is providing the recipe request and the current recipe is clear water. The external feed source option can be used as an alternative to feed requests originating from an irrigation system. For example, if the nutrient injector is configured to fill a series of large dilute tanks, which in turn are used to supply an irrigation system, there may be no need to couple the nutrient injector to the instantaneous requests from the irrigation system. The default feed recipe settings designate the default recipe to be used if the program cannot deliver the requested feed. This could occur when one or more of the stock tanks that are needed to make the desired feed are either empty or offline. Irrigation system requests are used to assign the nutrient injection program to an irrigation system. An injection system cannot be owned by more than one irrigation system, since it can only make one feed at a time. Once assigned, irrigation feed recipe requests originating in the irrigation schedules on this system are passed to this injection program as they are processed by the irrigation system program. Purge control. This option flushes the injector with water during a feed change and then charges it with the next feed. Purge verification can be used to ensure that purging operations are successful. After the purge duration timer has counted to 0, it compares the inlet conductivity to the purge conductivity reading. Charge verification can be used to ensure that optional charging operations are successful. After the charge duration timer has counted to 0, it compares the feed target conductivity for the new feed to the conductivity after charging reading. Depending on your system design, the charge conductivity reading can be either the nutrient injector conductivity reading or a downstream EC sensor at the purge valve. Recipe program assignment. Feed recipe programs must be assigned to the injection programs before they can be used. Use the recipe program assignment option to open this screen. The nutrient injection program can be linked to 8 feed recipes programs, for a maximum of 64 recipes per injector. All assigned feed recipe programs must be located on the same controller as the nutrient injection program. pH and temperature shutdowns are used to define the conditions for halting dosing based on pH and temperature readings. These settings apply to all recipes, default feeds, and clear water. Separate EC shutdown settings are located in the individual feed recipes. Stabilization delay lets you define a startup stabilization time during which the alarm shutdown readings and feedback correction values on the recipe screens are ignored. While stabilizing the alarm limits, timers are not allowed to increment. This allows longer-term problems to shut down the feed, but short-term stabilization issues are ignored. The stabilization delay time setting should set long enough to avoid nuisance shutdowns, but short enough to catch serious problems. Synchronized output groups are usually set by Argus technicians during system setup and commissioning. They are used to set up the pulse output period when using synchronized outputs. Synchronized outputs deliver their nutrients sequentially, one output at a time. External stop input is used to halt injection due to externally configured conditions. For example, a typical application may need to stop the injection system if the expected conductivity differs from the measured conductivity for a sufficient amount of time while feeding. The recipe calculation rules control the element calculation order when automatic injection volume calculation routines are used in the feed recipes programs. There are 4 modifiable lists and 1 predefined default list. These rule lists are common to all feed recipes programs assigned to this nutrient injection program. The nutrient injection program includes management alarms for monitoring the stock tank outputs and synchronized outputs. The use of emergency shutdown and restart settings is optional. They are intended to suspend operations during power outages and to delay and shed electrical loading when power is restored by spreading the startup sequence of equipment systems over a few minutes. Feed recipes programs work with the nutrient injection program to accomplish automatic nutrient dosing of multiple fertilizer recipes using the same injection equipment. The main screen of the Feed Recipes program displays menu entries for the 8 recipe programs, as well as a menu entry for alarms and installation and service screens. The system feed designation readings display the current designation for each configured recipe. Select a menu entry for a feed recipe to open the screen. Each feed recipe consists of a recipe window, a connectivity control window, and an injection control window. Recipe settings. At the top of each recipe window, you can enter a descriptive name for the recipe. A recipe must be set to enabled before it can be used by the nutrient injection program. You should disable the recipe temporarily while making adjustments to avoid dosing errors should this feed be called while you're in the middle of making changes. The recipe window consists of a table of columns and a menu entry for setting elemental targets. Elements A, B, and C can be used to set targets for any other materials you wish to administer. In the example, a recipe for feeding tomatoes has been produced from the target ppm screen and the available nutrients in the stock tanks of the linked nutrient injection program. Target ppm is where you set the recipe targets and limits. This screen is used to develop your target values. Conductivity and pH targets settings are used to calculate the target EC and the pH of the final solution. Select ratio of water to acid or ratio of water to base to designate either base or acid addition for this recipe. Enter an injection ratio for the designated pH concentrate. The optional scaling section is used to increase or decrease the target values over a defined start and end range based on a selected scaling value, for example parts per million. The target ppm column displays the results. There are 3 available methods for creating the target ppm values: single, scaled, and external settings. Single or absolute settings. In this mode you define an exact target value for each element that do not need automatic adjusting to compensate for changing conditions such as available light. Scaled settings allows each of the desired ppm values to be varied over a specified range in proportion to changes in a shared common scaling reading. External setting method allows the creation of a selected individual target ppm value using external programs such as math modules, equation programs, or sequencers. You can use all 3 element target methods together in the same recipe. Conductivity control is used to define threshold limits for this feed recipe that stops the injector when the measured EC reading deviates above or below the set limits, or if the EC reading deviates from the optional guard sensor by more than the set limit. The injection control section is used to determine a volume to be injected from the respective stock tanks that achieves the desired ppm in the dilute solution. They can either be automatic calculations or manual calculations. Manual control mode is intended for applications where the tank contents are always mixed the same and injected at a fixed rate. In automatic calculations mode, the program prefers all the volumetric and ratiometric calculations based on your targets and settings. It decides how much to inject from each tank to achieve your recipe. Automatic calculations provide extended operator control over which stock tanks are to be used, the order they're used, any elements of preference, and in some cases the minimum or maximum amounts of the total element targets to be drawn from tanks. For manual calculations, set each tank to either do not use, ratiometric volume, or injection volume. Select the EC feedback correction menu entry in the injection control window to open the EC feedback correction screen. The feedback correction routine uses the standard Argus PID calculations. Each feed recipes program contains tolerance settings and readings for recipe alarms. They indicate whether the respective recipe is or has been unable to provide the desired ppm values within the set tolerances. This associated tolerance alarm priority must be set to inform you of problems. Select an alarm priority in keeping with the urgency of a tolerance alarm. For more information on nutrient systems, watch the other nutrient series videos, or read the Nutrient Control Program's reference, Nutrient Systems, Nutrient Acid Injector, Multi-Feed RM, or the Dosing Handbook guides.